What is the solubility of X in mole per dm cube if 25.0 cm cube of its saturated solution contains 4.0 gram of X and X is equal to 60? So what I'm going to do, I'm going to use two methods to solve this. Method 1. So the first one, I'm going to use this formula, solubility is equal to reacting mass over molar mass times 1000 divided by the volume, given volume in cm cube. So this will be in grams. So if I apply this to this is going to give us the reacting mass is 4.0 grams. So I have 4 divided by the relative molecular mass, 60 times 1000 divided by the given volume is simple, that's 25. So when this cancel out this, we're going to have 40. This 0 will cancel out this. So we are left with 16 divided by 6. So when I divide this out, this is going to give me 2.67 approximately mole per dm cube. Alternative, we can also solve it at using this formula. So I'm going to call this method 2. In method 2, this is what I'm going to do. Molar concentration C is equal to amount in mole divided by the volume in dm cube. So we are going to calculate the amount in mole. That is M is equal to reacting mass all over molar mass, also in grams. So the reacting mass from the question, the reacting mass is 4. So you have 4 divided by the molar mass, 60. And that will be equal to 0.06 approximately 7 moles. Okay, so the volume in dm cube would be equal to the given volume 25 cm cube divided by 1000. So we have to convert that to dm cube. So that will equal to 0.025 dm cube. So now we can now go back and apply our formula here. So we're going to have C is equal to 0.067 in mole divided by 0.025 in dm cube. So that will give us 0.067 divided by 0.025, which is approximately equal to 2.67 mole per dm cube, which is the same as what we had before. Okay, example 2. If the solubility of KHCO3 is 0.40 mole per dm cube at room temperature, calculate the mass of KHCO3 in 100 cl cube of the solution at this temperature. So simply I'm going to write the solubility is equal to the reacting mass all over molar mass times 1000 divided by the reacting volume in cm cube. So the solubility here is given as 0.40. So I'm going to have 0.40 equals, we're asked to calculate the mass of this, that's the reacting mass, which is X, divided by the molar mass, which is given as 100 gram per mole, times 1000 divided by 100. So you can cancel out this. This will cancel out this. So we're going to have x is equal to 0.40 times 10, which is equal to what? 4.00 grams. So that's the amount, the mass of KSO4 that is present in 100 CMQ, having a solubility of 0.40. Again, you can also work this out by using concentration. As molar concentration is equal to N all over V in DMQ. Okay, so it means that we have to convert this to DMQ by dividing by 1000. So we have 1000. So the volume will be 100 divided by 1000, which is equal to 0.1 DMQ. So if we substitute this into this, we're going to have N is equal to CV. So that's if I cross multiply. So N will be equal to the concentration of 0.40 times 0.1, which is equal to 0.04 moles. So if we now apply this, number of moles is equal to reacting mass over molar mass. So we're asked to look for the reacting mass. So from here, you can simply see that X is equals to number of moles times the molar mass. So S will be equal to 0.04 times 100 is equal to 4.00 grams. So whatever method you use, you still arrive at the same answer. Okay, question 3. What volume of 0.20 mole per DMQ of sodium hydroxide solution will use 5.0 gram of sodium hydroxide on evaporation to a dryness? Molar mass of sodium hydroxide is 40 gram per watt. Well, again, I'm going to use solubility is equal to reacting mass over molar mass times 1000 divided by the volume in centimeter cube. So this is the volume they asked us to look for. So the solubility is 0.20. That's equal to the reacting mass, that's 5, divided by the molar mass, 40 times 1000 all over V. So this will cancel out this. And for here, we have 25. So 0.20 is equal to 5 times 25 is 125 all over V. Then cross multiply. When cross multiply, we have V is equals to 125 divided by 0.20. So that will be equal to 125 divided by 0.20. That's equal to 625. So the volume is equal to 625 cm cube. Now for method 2, I'm going to use C is equals to N all over V, or you can just simply say N is equal to CV, which works either way. So in this case, we have to look for V in mole per dm cube. So first of all, we have C. The concentration is 0.20. So I have 0.20 is equal to the number of moles present. The number of moles present, N, will be equal to 5 divided by 40. Remember that? The reacting mass over molar mass. So 5 divided by 40 is equal to 0.125. 0.125. So I'm going to substitute that 0.125 divided by V. So from here, you can see that V will be equal to 0.125 divided by 0.20. So when I divide that out, that's going to give me 0.625. This is in dm cube now. So to convert it to cm cube, we multiply 0.625 times 1000. So V is equal to 625 centimeter cube, which is the same as before. Okay, water is added to 120 gram of a salt MCl to produce 60 cm cube of saturated solution at 298 Kelvin. The solubility of the salt at that temperature was 8.0 mole per dm cube. calculate the mass of the salt which remained undissolved. M is 24, Cl is 35.5. So we are going to get the relative molecular mass of this, and this, there should be 2 on this. So there's a 2 there, so we'll calculate this. So I'm going to have the molar mass of MCl2 will be equal to 24 plus 35.5 times 2, and that will be equal to 24 plus 35.5 times 2. That's equal to 95. That's 95 grams per mole. Okay, so having got it, that we'll use the solubility formula. Solubility is equal to reacting mass over molar mass times 1000 divided by the given volume in cm cubed. So the solubility here given is 8.0. Now you need to look at something, that water is added to 120 grams of a salt. Some part of it would dissolve in water at that temperature. So not that this 120 grams is what we are going to. We are not using this 120 grams because part of this 120 grams will dissolve. So that is what we don't know. We have to calculate that out now, which is x. So the solubility is 8.0 is equal to x all over molar mass. That's 95 times 1000 divided by the reacting volume, which is 60. So I'm just going to work this out. I have 8.00 is equal to 1000x divided by 95 times 60. That's equal to 5700. So when I cross multiply, so I'm going to have 8 times 5700 divided by 1000 is equal to s. So this will cancel out this, and I'm going to have 57. 8 times 57 divided by 10, that's equal to 46.5. So x is equal to 45.6 grams. So the amount of solute that dissolves in the water, in this water, was 45.6 grams. So in the question, we are asked to calculate the mass of the salt which remain undissolved. So the mass that remain undissolved mass will then be equal to 120 minus 45.6. So 120 minus 45.6 is equal to 74.4 grams. Okay, you may want to try this with the other method. So trying this with the other method, we're going to use N is equal to CV. So we do not know what N is, so we have to calculate N first. So N is going to be equal to C, as 8, times V. The volume given is 60. We'll have to divide it by 1000 to convert it to dm3. So N is equal to 8 times 60 divided by 1000. That's equal to 0.48. Number of moles is equal to reacting mass all over molar mass. So from here we can say that 0.48 is equal to the reacting mass x all over the molar mass, which we calculate as 95. So from here we can say that x is equal to 0.48 times 95. It's equal to 45.6. So x is equal to 45.6. So the undissolved mass will then be equal to 120 minus 45.6, which is equal to 74.4, which is the same as what we obtained in the previous method.